Hi everyone, welcome to this session. Failure is not an option, durable execution plus Dapr is amazing. If you're working in IT, then you probably know that failure is inevitable. You probably see it every day. We see like new bugs appearing every day that we need to fix. There's like outages at cloud providers. It always seems to be like DNS. Failure is everywhere, so we need to take that into account. And maybe you're as old enough as I am and that you've seen this information message from Windows XP a long time ago. And it says, task failed successfully, which is of course a very weird thing to show to your end users. But the message is actually what it's about in this session. Things are failing. We better ensure that things are failing successfully and limit the impact so end users might not even notice that there were failures. I'm Marc Duiker. I'm a developer advocate at Diagrid, a company founded by the co-creators of Dapr Open Source, and we build solutions in the Dapr ecosystem. I'm one of the Dapr community managers. We do live streams every month, and we also manage the Dapr Discord, so if you're not there yet, please join the Dapr Discord. I'm also one of the Microsoft MVPs, and I do love knowledge sharing with Twist. I also like pixel art a lot, so that's why you see this up here as well. If you want to know more about my creative things, have a look at marcduiker.dev. When I did some research about IT failures, I came across this very old blog post on the IEEE Spectrum blog. So it's a very respectable blog site, and it's called Lessons from a Decade of IT Failures. And this is a really nice blog post. I highly recommend everyone to look into that. We will share the links later as well. But it looks into all kinds of IT failures between 2005 and 2015, and it's also like a very interactive report as well, as you can drill down into some of the issues in that report. I just took a screenshot of the first one, where you can explore what the monetary cost has been between 2005 and 2015. And well, the legend here with all these circles indicate how big the cost is. So the biggest one is worth 10 billion in IT cost. And if you scroll down here, then we see it by region, and also here on the x-axis the time. So in this 10 years, there were like a lot of very big IT failures, which cost like over the hundreds, probably even thousands of billions in IT cost. This may not be a surprise for you. But yeah, the scale and the size of this is really impressive. And I'm not saying by following the tips that I will share in this session, this will be completely gone. Definitely not. There will always be IT failures. There's many reasons of IT failures. But I think a lot of these failures can either be prevented or the impact can be limited. All right. So a lot of organizations are building distributed applications. So applications that involves a lot of different services, different state stores, maybe even different message brokers. And these are quite complex things to build. And it's not that organizations want to build distributed applications, but typically they are forced to do it because they have like dozens or maybe even hundreds of development teams. Maybe they're using different technology stacks. So it's inevitable that you end up with distributed applications. And we've known for quite a while that it's actually hard to build these distributed applications. So there's this fallacies of distributed computing, which is quite well known, but that's already from 1994. And that is a set of false assumptions programmers new to distributed applications often make. I will not list all of them, as this is not a very theoretical session. I definitely recommend you to look into the links, especially the last one, because that's like a YouTube playlist where Udi de Haan from Particular Software gives an explanation about all these fallacies. So I think it's very interesting to look into these a bit more. It's also very good to understand there are different types of failures, and one of the axes that you can look to categorize failures is are they temporary or transient, or are they permanent? Right, so transient failures are temporary and they're usually resolved themselves without any human intervention. It's good to realize that when that happens, it means that someone else before you has thought about this specific edge case and made it so it's not an issue for you anymore, right? So maybe someone fixed something in hardware or in firmware or in software that things will keep on working eventually. And that's also the area that we'll look into a bit further. The other type of failures, those are permanent failures. So those are the opposite of transient failures, and they do require human intervention to be resolved. So you could think of maybe someone introduced a bug in the source code. Well, that's not going to be resolved automatically. Someone needs to go into that source code, update it. You need to rebuild and redeploy it. So that requires human intervention. Now, looking at distributed applications, there is a open source project called Dapr. That stands for the Distributed Application Runtime. It's been out there like almost 6 years now. It's a graduated project within CNCF, and it's been used by a lot of enterprises to build distributed applications. And it has really proven itself over the years. And so large organizations use this and are very successful. And one of the benefits actually is that developers are also much more productive when they use something like Dapr versus not using Dapr. So how does Dapr actually help you building these distributed applications? Well, Dapr actually decouples your application layer from the underlying infrastructure layer here at the bottom. So you can write your application in whatever language that you want. Dapr sits next to your application, so it uses the sidecar model. And that really helps you to quickly build applications that, for instance, need like pop-up messaging or service verification or do some state management. All of these functionalities are built into the sidecar, so you don't have to write that into your application. You just need to invoke these functionalities on the sidecar. Another benefit is that it also provides built-in observability, security, and resiliency. So again, you don't have to include all these features yourself in your own application because the sidecar will take care of that. So you shift some responsibility towards your sidecar so you can focus on your business logic in your own application. Now, as you can see, the Dapr sidecar offers lots of different APIs and features. In this session, we're only looking at the workflow one, but it's one of many different features. If you're unfamiliar with Dapr, I can definitely recommend you to have a look at Dapr University. We offer this for free. The only thing you need is like a name and an email, and then you get a cloud-based environment, like a sandbox environment, where you can run Dapr applications and test out how it works. So please try that. So going back to the problem that we're solving. So we know that systems are failing. We need to recover from failure, ideally automatically. So these transient failures. And we need to limit the impact of failure, right? Because it's inevitable. So if we fail, let's make sure that we limit the impact. So one of the things that can help us are job execution systems or workflow systems. Now, what is job execution? Job execution guarantees that code is run to completion even if the process that runs the code terminates. So job execution ensures that another process is started and that the code is resumed until it completes successfully. And this is realized by persisting the state of execution to a state store. Now, if that sounds familiar, maybe you've used workflow systems in the past, because workflow systems have been around literally for decades, and they are used to automate business processes, and they implement this job execution concept. Now, workflow systems consist of three different things. So usually you have an authoring environment to create the workflow. Then you have like an engine which actually schedules and executes the workflow, and there is a state store to persist that workflow state to make it durable. Let's have a look how most of these systems work. So here we see a representation of the workflow, and there will be a lot of interaction between the workflow engine and the state store. So as soon as we start the workflow ID and input will be stored. Then the first activity is scheduled, so the input for that will be stored. This will be executed, but when it's completed, also the output will be stored. Then we won't immediately go to the second activity, but the workflow will replay from the start. It will get the information for the first activity from the state store. Then it will schedule the next activity. And again, it will store the input, it will store the output. Then again, it will replay from the top. It will hydrate the state back from the state store, and then it will do activity 3. And finally, once activity 3 is done and that state is also in the state store, it will replay again for the final time, and it will get all of the results back from the state store. And then our workflow has actually come to completion, and then also the workflow state and output of the completion will be stored in the state store. So as you can see, there's a lot of I/O happening between the application, the workflow engine, and the state store. So this is important to realize, especially when you start debugging workflow applications. So one of the workflow engines is Dapr Workflow, part of the Dapr project, and it's using the durable execution concept by persisting workflow state in a Dapr compatible state store. If you're already using Dapr, then it's very nice to use Dapr Workflow because Dapr Workflow works seamlessly with all of the other Dapr APIs. So Dapr Workflow uses a workflow as code format. So you write your workflows in the language that you're comfortable with. So it's like C# or Java or Python, JavaScript or Go. And you can apply lots of different workflow patterns. So let's look into that shortly. Here's like a typical but small workflow example that shows you what kind of steps you can use in a workflow. So you typically start by receiving a message, either from a message broker or maybe it's just an HTTP call. Then you apply some business logic inside your workflow. In this case, you call an activity, and that uses a Dapr API to retrieve a secret, and then it makes a service verification call to another service. Then it will continue, but there it will wait for an external event to come in. Once this event has come in, the workflow will continue, and then it will do activity B and C in parallel. So it stores an event result using the Dapr client, so the Dapr State Store, and it invokes another API. And finally, in the last activity, we publish a message to another message broker, and then our workflow is complete. Now, I already mentioned that workflow authoring with Dapr Workflow is via code. Personally, I like it a lot. I have a developer background. I like writing code, so I really like that you can author your workflows as code because that's very understandable to me. I also like it that it can be unit tested easily, and so you can really prove that your business logic works. And it's also part of source control, and so you make like pull requests. People can review it, so they can also verify that your workflow is actually sound, that the business logic is good in there. Downsides of workflow as code approaches is that typically there's no visual representation of the workflow itself. There are a lot of workflow as code solutions, right? So in this session, we're looking into Dapr Workflow in a bit more detail, but there's also Temporal. If you're familiar with Azure there and Azure Functions, there's Azure Durable Functions. If you know Azure Durable Functions, the API is like 99% the same as Dapr Workflow. So it's very easy to go from Durable Functions to Dapr Workflow because you will definitely understand the API. If you are interested in general about these Drupal executions or workflow engines, on GitHub there's a GitHub repo called Awesome Drupal Executions, and that lists like dozens and dozens of these systems, so you can do a bit of comparison if you want. And of course, all of these links will be put into the description, so you can have a look at it. Let's look into some workflow patterns, because if you're working with workflows as code, there are some very typical workflow patterns that you actually need to use. And sometimes these things work a bit differently than you would program your application without using workflows. So the first one, and that's the most basic one, that's called task chaining. So task chaining is where the order of execution of the underlying activities is of importance. And it is because maybe there is an output of activity A that's used as an input for activity B. And the output of activity B is used as an input for activity C. So that really requires this specific chain of these activities. And by the way, your workflow typically consists of calling these activities, some if-else statements, but that's it, right? So all of the code that you would do otherwise, all of the non-deterministic code, like calling out to a database or calling out to a service, all those things are wrapped inside an activity. Next pattern is the fan-out, fan-in pattern, and this is very useful if you want to execute multiple activities in parallel, which you can do when there's no relationship between these activities, right? So there's no output that needs to go into another activity as an input. And you can either call different activities, but you can also choose to, for instance, if you receive an array as an input, you can also call the same activity, but then for each input for the array. So you can use this in different ways. So it will do the fan out, so it will schedule and execute all of these activities, but then the fan in part is also very important. So Dapr Workflow will schedule all these activities so that they will run, but the workflow will actually wait here until all of these activities have been completed, and then you can still do some aggregations at the end with the output of all these activities. The monitor pattern is very useful when you want to do some kind of a recurrence of an activity. So for instance, you want to run a nightly cleanup job to clean up some resource in the cloud. Well, you can call your cloud API to do the cleanup job in this first activity. So this makes a service invocation call or some other call to a third-party API in this activity. Then next you will use a timer in this workflow application to wait. We're going to wait 24 hours before we want to run again. But now we are using the continue as new method, and this instructs the workflow to start as a fresh instance and forgetting all of the historical executions. So this is basically like writing a loop, but in a workflow code, you should never do like a do-while loop, for instance, but you should always use continue as new as a loop. Because when you use this method, you can always provide some new input for that can be used inside the workflow when you do this loop. The final one is external system interaction. That is very useful if you want to workflow to wait until an event comes in. So for instance, maybe you have like a typical order approval workflow. So maybe you want to order like a new laptop and that's above a certain budget, and above a certain budget you need manager approval. So that's a very typical use case for the external system interaction. Then there's also child workflows. So you can have like one parent workflow that calls other child workflows. So this is quite useful if you want to do some kind of a workflow composition, because workflows can become like very large. So maybe you have like a workflow that calls 100 different activities. Well, that can be hard to see in one file. So what you can do is you can group certain activities together if they logically make sense together as a unit. And you can make that a sub-workflow, and then your parent workflow can do orchestration of these child workflows. Okay, let's have a look under the covers of the Dapr Workflow engine. So the blue hexagon here is your workflow application. So this contains your workflow code that you've written, and the activity code as well. Maybe some other services to actually start and stop the workflow. And this is the Dapr sidecar that runs next to your application. And the Dapr sidecar contains the Dapr Workflow engine. Now, as soon as the system starts up, there will be a communication, a gRPC stream set up between your workflow application and the Dapr sidecar. And the Dapr sidecar will detect if there are any workflows defined in your application. And if there are, it will also check against the state store if there are any workflows that haven't been finished yet. And if it is, it will actually schedule the workflow to run again and to actually finish the workflows that have not been completed before. And yeah, during the lifetime of your workflow, there's going to be a lot of communication between the Dapr sidecar that will schedule the workflow app will do the execution of its own workflow steps of all the activities, and there's a lot of interaction between the workflow engine and the state store. Now, Dapr Workflow is built on top of Dapr Actors. So Dapr Actors is one of the other Dapr APIs. It's not you won't interact with these actors yourself, because the Dapr Workflow engine will do all the interactions with the underlying actor system. But I think it's useful that you know that it's built on top of Dapr Actors, because you do see, especially in the Dapr D logs, you will see that there's some actor communication going on there. So there's an actor that takes care of all of the different workflows. That's the orchestrator actor. And there's an actor for each type of activity. So there's different actor types in play. And these actor types, they are stateful, so they persist their orchestration state and activity state to this append-only state store. Okay, now it's time to look at the demo. So the demo consists of a workflow application that contains, of course, our workflow definition and activities. We'll soon see that. And that will interact with a state store, the inventory, and it will interact with a separate service via service invocation, the shipping one. And this is the diagram of the validate order workflow. So it does some kind of order validation before we actually place the order. So what happens is when we started with an order payload. Then we first do an update inventory where we use the Dapr state management API to communicate with the inventory. If the inventory is sufficient, then we check what are our shipping providers for this order. So this will get back an array of different shipping providers. In this case, it's hard-coded to 3 shipping providers. And then we do an iteration for each of the shipping providers, and we get the shipping cost. Then we choose which one is the cheapest, and for the cheapest shipping provider, we will register this shipment. So we will do another service verification to our shipping service. If that's all successful, then we end. If this last one, if this is not successful, then we are going to undo this action. So this is called a compensation action. So this is wrapped in a try-catch. I will show you the source code in a second. So if this fails, then we actually have a separate activity where we are undoing the stuff that we did here. Because here we already made an inventory update. We're actually lowering the inventory based on the order size. But if we can't register the shipment, then we need to undo that. And so this is totally, of course, this can be anything, right? So this is totally up for your specific business needs. Okay, let's have a look at the solution file. So this is the CS project file of the workflow app. It's a web application, .NET 9. The only dependency that we're using here is Dapr Workflow 1.16. That's the latest version. Dapr 1.16 was released 2 weeks ago. Let's look at the validate order workflow itself. So as you can see, a workflow is just a .NET class. It inherits from a base type. It's a workflow base type where you specify the input and the output type. And this base type is from the Dapr Workflow package. When you inherit, you need to override this run async method. And the run async method has like a default parameter, that's the workflow context. And you use the workflow context to call activities and do other things in the workflow. And you have the input for this workflow. So this is an order in this case. Okay, so let me just describe what happens inside this workflow. Again, it's already visualized in the diagram, but let's have a look at this code. So, so the registration shipment result, that's our final result of the registration. We'll see that later. The first thing that we use the context for is to call an activity. And you call an activity by first providing the output type of the activity. In this case, it's an inventory result. We are calling the update activity. And notice that we are using the name of. So when you call activities, you always refer to activities by name. And you provide the payload. In this case, it's an order item that we're using here from the order. We are awaiting this call. So what happens here is that the workflow will schedule this activity, but the workflow will wait until this call, this activity has completed and will come back. Then we have this inventory result, and then the code will continue. So we can then inspect from a property of this return value, is there sufficient stock? And if there is, then we will continue. Otherwise, we just stop the workflow. And we again are doing a activity call, but we're now calling the get shipping providers. So this is the name, this is the payload, this is the input. But now we have another parameter set, and those are the workflow task options. So what you can optionally provide is a retry policy when you are calling activities. So and that's what we're doing here. We didn't do it here. So in this workflow task options, we create a new workflow retry policy. And here you can use different kinds of values. In this case, I've set it to max number of attempts, and it will retry a maximum of 3 times in case it fails. And in this case, it will try it in a constant fashion, but you can also use like exponential backoff and then mention how long the maximum duration will be, etc. So it's important to realize when you can use retry policies within code, right? And then that's very useful when you have activities that do not use any other Dapr APIs inside the activity. If you, for instance, use Dapr pops up, or you use Dapr service verification, or the Dapr state management, all those APIs already have built-in resiliency policies based on Dapr. So it's recommended that you either use the Dapr resiliency policies that are built in, but in case those are not available because you're calling a third-party API and that has nothing to do with Dapr, then you can use this workflow retry policy. So we have the get shipping provider result, which then has a list of shipping providers. So what we are doing then here is we are iterating over these different shipping providers. And for each of these providers, we'll make a new request. And then we use the context again, call activity async. This is the output that we expect, shipping cost result. And we are calling the get shipping cost activity and giving this request. But note that something different is happening now, because we do not await this context call activity async. So what happens here is this shipping cost result task is a list of task shipping cost result. So what we're doing here is we are adding to a list of tasks. So what we end up here after is for each is that this is a list of tasks that we want to execute. So this is the fan out, fan in pattern. So at the end here, we have a list of these tasks that we still want to execute, and the execution part happens here. So here we do await task when all, and here we provide the list of tasks. So this is both the fan in, but also the fan out, what's happening here. So the Dapr Workflow engine will now schedule all of these tasks and run them in parallel as much as possible, but we're also awaiting until all of them have been completed. And so the workflow will stop here. It will wait until all of these tasks are done. And once these are done, we have now an array of shipping cost result. And we can expect that, and we are using the min by here and using the cost parameter property from the result by choosing the cheapest shipping service. All right, the next part shows how to deal with compensation action. So what we have here is we have a try catch block. So in the try block, we are doing an await call activity async, and we call the register shipment activity. And this will reach out to another service. I'll show you that soon. But in case this results in an exception, we can catch it. And these exceptions will always be wrapped in a workflow task field exception. So you can check for that. Of course, you can also check what the inner exception is here. But in case this goes wrong, we can do something else. And that's our compensation action. And in this case, I have defined another activity called undo update activity. That will use the Dapr State Management API again to undo the update inventory that was done at the beginning of this workflow. Okay, so that's the entire workflow. Let's have a look at an activity. So this is the definition of an activity. Again, it's just a .NET class, and then we inherit from workflow activity, again providing the input type and the output type. This activity uses the Dapr client to interact with a state store, so that's why we have the Dapr client here, so that's being injected. And again, you need to override the run async method. We now have a workflow activity context. You probably don't need to use it unless you need the workflow instance ID, and this is the input for the activity. So what happens here is we use the get state on the Dapr client to actually retrieve the product inventory for this order. And we do a quantity check to see if we have enough in store. If we have enough in store, we create a new updated inventory and we save that using the Dapr client. Okay, let's have a look at another activity that will make a service invocation call using Dapr. So that's the get shipping cost activity. So here we are injecting the HTTP client. So that will actually make the call to the other service. Again, the run async method needs to be overridden, and that's what's happening here. So we use the HTTP client and we are doing a post then to the calculate cost endpoint on the shipping service. We only see an endpoint here. We don't see an actual address of the shipping service, and that's because Dapr will actually figure out where it is based on the name, and I'll show you in a minute where that name is defined. So this is inside the shipping service. So this is the calculated cost endpoint. I have like a bit of thread sleep here, but this is just to make sure I can run the demo smoothly, but you'll find out soon enough why. And it uses a bit of like a randomization to determine at random what the shipping cost will be. Okay, going back to the workflow application. So this is the program CS file of the workflow application. Here you see that we register the HTTP client and we use the Dapr client to create an HTTP client, and we provide it with one argument, and that's the app ID. So the app ID, all Dapr applications require an ID, a unique identifier. So this is for the shipping application. So if we use the injected HTTP client, Dapr will understand that how to find it, because we have specified that it's the request we are making are towards this shipping app. So that's how it knows how to find it. One important thing about Dapr Workflow in .NET is that you need to register your workflows and activities to the services collection. So there's an add Dapr Workflow extension method on the services collection. So here you need to register your workflow and register activities. In some of the other languages, you don't have to do this, but in .NET you have to do this. So don't forget this. Otherwise, the Dapr sidecar doesn't have any clue that you have workflow code. We will start the workflow by calling this validate order endpoint. And when we call this, there is a Dapr Workflow client that's been injected, and we use the schedule new workflow async method on that client to schedule all our new workflow. We provide the name of the workflow, we provide an instance ID. This is optional, so if you don't provide an instance ID, Dapr Workflow will generate one for you. But in this case, we are reusing the order ID as the instance ID. And so each workflow execution has a unique instance ID, and you need this instance ID if you want to do some other stuff with the workflow, like getting information or pausing it or resuming it, etc. That's also what you get back. So in this case, we provide an instance ID, and we are also getting the same instance ID back. That's also important to realize, because we are not getting back the result of the workflow here as an output parameter, because a workflow can be long running. It can take like hours or days or months, or it can even be an eternal workflow that never ends. So what you get back is the instance ID, and you use the instance ID to query the workflow state later. There are also some other endpoints that I'm using to actually make sure that I have enough stock to actually make the order. All right, when you run workflows, as I mentioned, workflows are based on Dapr actors. So it's important that you actually configure your state store in such a way that the actor state is set to true. Otherwise, Dapr workflows will not work. Okay, I'm almost ready to run this. So what will happen now is I will use Dapr CLI to run this Dapr application locally. And I do this with something called multi-app run. So there's this dapr.yaml file, and that contains like the different definitions of the applications that I will be running. So there's a workflow application in this folder, and there's also a shipping application in this folder. So when I run the Dapr command, both of these applications will be up and running. I'm also pointing to a specific resources file that contains the YAML and potentially any other resources that Dapr might need, like component files. Okay, what I'm going to do now is I will start the workflow app and also the shipping app. I will then make a request to this workflow app to start the workflow, but then I want to simulate that something bad happens. And something bad in this case, I will stop the workflow application, I will stop the service, the shipping application, and also the Dapr process. So I will stop everything to indicate that there's some kind of an outage. Then I will just restart the Dapr applications again, and then we see the power of job execution. So let me first build the .NET applications. So this is the shipping app that's being built. Right, and the workflow application. Okay, so let's start running it using Dapr run-f dot. So this will now read the dapr.yaml file. So both applications will soon be up and running. All right, applications are up. So now I'm first going to make sure I have enough inventory so I can actually make the order. I am using a REST client in VS Code, which allows you to write your endpoints like this. And there's also like a little button here called send request, so I can click that. So then I'll make a request to this endpoint /inventory/restock, which has a certain product ID and a quantity of 5. So let's do that. Okay, I get back to accept it, so I have enough stock to now to order it. Now I'm calling the /validate order endpoint, and now my payload is an order ID, and it's using some variables. So this is like a randomly generated thing. So I'm going to send a request, but very soon then I will stop all of the applications to indicate or to simulate there's an issue. So making the request, and I'm stopping everything. Now I will scroll up a bit here in the logs. because the last thing that happened in the workflow is that it reached out to the shipping application. So this is a log statement from the shipping applications, shipping service C, shipping service A, shipping service B. So because we are now in the process of getting the shipping cost. But at that moment, shipping service is down, workflow app is down. So something serious happened. All right, now I will restart the applications, but I'm not triggering this validate order endpoint again, right? Because our workflow was executing, now it stopped, but some state is in the state store about this workflow. So Dapr will actually figure out what's happening. So I'm just restarting the Dapr process and that's it. All right, so our application are running. So now we are at the same situation, shipping service C, shipping service B, shipping service A, and now it will continue to shipping service A, and we see that orchestration status is completed. So we can also check this endpoint on the Dapr sidecar by specifying this instance ID. So by making this request, we can get the latest status of this workflow execution. So I get back at 200 OK, and this contains the payload of for this instance ID, this workflow name, the validate order workflow. We can see when it was created and last updated. We see that the runtime status is completed, and we also see what the input was and the output was. And so this is the power of Dapr execution. Something bad happened. We are only restarted the Dapr process, which if you're running on Kubernetes, that will happen like automatically. And then it got back in a good, healthy state again because it just the state was stored in the state store. It could just rehydrate the state and continue. Okay. The other thing that I can demonstrate is the compensation action. So again, we can simulate an issue by returning a status code 500 from the shipping application where we register the shipment. So at the moment, the register shipment endpoint returns an OK, 200. Let's change it to return a 500 server error. Let's rebuild this shipping application now. All right, and we are going to run the app again. Okay. Now we do have to start over because there's nothing, there's no workflow running anymore. So let's make sure we have enough inventory, and we can now start a new workflow. We won't disrupt it now, but now the register endpoint will throw a 500. So that activity will be retried a couple of times. Those will all fail, but then Dapr Workflow engine will actually execute the compensation action. So let's make this request and let's see how this plays out now. So we're now calling the shipping application for the cost. That's fine. We're now doing the register shipment, and we can already see orchestration status completed. So the workflow is completed. But now if we look at the undo, yeah, here you can see that we have called the undo update inventory, and we have reverted the inventory update for this product to quantity 5. Right, so we've shown Dapr execution pattern in action, but also how you can do compensation actions. Let's move to workflow management, because just starting workflows and getting information is not enough. You need to do more things with workflows. So what you can do with Dapr Workflow is, besides starting a workflow instance and getting that instance state, is you can also pause a workflow. So maybe you have like a very long running workflow, or like it's an eternal workflow, and something is not working, so you need to pause it and fix something and then continue. So you can definitely do that. You can pause it, you can also resume it. You can also terminate a workflow instance. So maybe a workflow went completely wrong, you need to get rid of it, you can terminate it. So this is not terminating the application, this is just terminating the execution of a workflow instance. And finally, you can purge the state of a workflow instance. So it's important to know that by default, Dapr does not remove any state information from the state store. So if you're running many workflow instances, your state store will grow and grow. So you need to have like a strategy how you deal with that. And you can either use the Purge API on the workflow management part, or you use some kind of other retention strategy on the state store itself to clean up this data. What's also important to realize is that all of these methods require the instance ID of the workflow. So all of these operations that you do, you only affect one workflow instance. Okay, the final section, and it's about workflow challenges and tips. Because sometimes it can be tricky to get workflows right because it's just a slightly different thinking or programming model that you're used to. So one of the big things is that workflows should be deterministic. And that means running the workflow with the same output should always result, with the same input, should always result in the same output. And why is this? Well, I've already shown in the animation that your workflow code will actually be executed multiple times over and over in this replay phase. And in this replay phase, all of the inputs for an activity will be matched against what's in the state store. So if there's some kind of a mismatch between what's happening at runtime in the workflow engine and what happens in the state store, if there's a mismatch, well, then there's no guarantee that your workflow will be deterministic and will have like a good output. So very practically, here's an example of a non-deterministic workflow that uses like non-deterministic code inside the workflow. So anything that needs to do with like randomization or date times, you should avoid. So for instance, don't use like GUID new GUID in your workflow, or don't use like datetime UTC now, because during a replay, this will get like a new value, and this as well. And if you're using these as arguments to your calling activities, and this is like a recipe for disaster, because this will lead to mismatches. For these two situations, there are good things, right? So for instance, there are different methods that you can use. So the context has some additional methods. So there's like a new GUID method on the workflow context that you can use. So this is safe for replay. So this you can definitely use. And there's also like an helper property to get the current UTC datetime in a replay safe way as well. But yeah, like I mentioned before, inside your workflow code, there should also only be like calls to activities, business logic, so if-else statements, but don't do any like non-deterministic things like calling out to endpoints directly from your workflow. Those things all need to be wrapped in activity calls. Another important part is that activity should be idempotent, and that means that running the activity multiple times should not result in any side effects. And this is because Dapr Workflow guarantees at least once execution if something goes wrong in the activity. And well, you can imagine that maybe your activity contains like several lines of code, and maybe the failure happens at the final line of code, but all of the other statements before that have already been executed. So Dapr Workflow will then retry to execute your activity again. So what happens when you retry those lines of code? So is that safe for to be executed again? For instance, if you do a database insert, can you do a database insert with the same primary key, for instance, right? Probably not. So maybe it's safer to first do a read and then do a write, or maybe you need to do an upsert. But also think about like third-party SDKs, right? Do the methods on those third-party SDKs, are those idempotent as well? So can you invoke them multiple times without having side effects? Then there's workflow versioning, which regardless of which engine you use is very difficult. It's very easy to introduce a breaking change in a workflow that will result again in a mismatch between the persisted data and the data at runtime. So you can imagine you made a change to your workflow. Maybe you have inserted a new activity, or you're changing some types, some input types, some output types. You deploy again, but when you deploy, maybe some workflows are not completed yet. So those are called in flight. So those are not completed, but the state is still persisted in the state store. You have deployed your new workflow, but now the data in the state store doesn't match anymore your new workflow model. And that's a bad thing. That's not something you want. So at the moment, there's nothing built into Dapr Workflow about versioning, but I think it's very likely that 1.17 will include something like that. But at the moment, you have to do something yourself about workflow versioning. And there are different solutions. For instance, you can apply a version suffix to the workflow name. Yeah, so you start with my workflow v1, and then when you want to make a change, you don't make a change to workflow v1, but instead you copy that, you give it a new name, workflow v2, and you make all your changes in there. The consequence of the downside of it that your client that manages the workflow, that starts it and that stops it, that needs to know about the updated name. So maybe you're in control of that, maybe it's the same service, then it doesn't matter. But if it's like a completely other service that starts or manages your workflow, then it might be tricky. Another strategy is that you wait until there are no more in-flight instances before like deploying the new version. Maybe you are lucky that maybe there's a time window during the night when it happens. That might be true. But yeah, the very tricky thing is you have to get insights in that there is really nothing running at the moment. And that's at the moment is very tricky to know that nothing has been started or nothing is not completed yet. Another option, which is definitely safe to do, is like do blue-green deployments, right? So you keep running the old version and then you deploy a new instance at another resource. So the old one can still run or execute the in-flight instances, and once those have been completed, then you can get rid of the old instance. It's definitely more complex and also costly to set up because you need to have like 2 active instances, and you also still need to monitor when the in-flight executions, when they are completed. And yeah, at the moment there's not really a good way to do that yet. The final one is about payloads. So it's always recommended to keep like the payload small between activities. Because workflow and activity inputs and outputs are always persisted to the state store and are like serialized and deserialized all the times. So keeping payload small helps you to achieve like a good performance and also doesn't take up too much storage space. So as an example here, called a large payload size workflow. So let's say we have an activity that will return a very large JSON document by calling this document. So what we have here is a very large object as an output, and we're using this document as an input for the next one, update document. But what happened behind the scenes is that this document will be stored as an output for this activity, and it will be stored as an input for this activity. So it will be stored twice. And so that's really not very efficient. So what you should do is use, of course, IDs as much as possible between activities, but sometimes you should also like group certain functionality inside one activity. And so in this case, instead of doing like a separate get and an update, we do and a get and an update and save all within the same activity, so we don't have to do anything like passing big documents around inside a workflow. All right. I hope I've shown you some tips how you can actually do or actually have successful failures with Dapr Workflow. If you want to know more about Dapr Workflow, there is a lesson, a track on Dapr University called Dapr Workflow, Use Job Execution to Build Reliable Distributed Applications. It's about like 45 minutes to an hour lesson that goes deep into all of the different workflow patterns that I've just shown you. It's available in .NET, Java, and Python, so give that a go if you want. If you need some help in actually writing or generating code for your workflow applications, you can try out our Workflow Composer. It's a tool that uses a bit of AI based on diagrams that you can either create here or upload. It will actually create real Dapr workflow applications in any language that you want. And well, finally, thanks for joining this session. I hope you learned something new about Dapr Workflow, and feel free to scan this QR code and become like a Dapr community supporter. Thanks.